Hello students. So, how's your studies going on? I hope every one of you must be polishing your brains with learning the concepts from your classrooms and the textbooks. So, do you want to explore more in this creative world of education? Let's explore it. Let's study one of the basic concepts of science, which is the ray optics. So, what does this ray optics means? Ray optics basically deals with the propagation or travel of light in a particular homogeneous medium. Now, what do you mean by the homogeneous medium? Homogeneous medium means that where properties remain same at every point. That means this is the ray of light, this is the ray of light, and this is going in a homogeneous medium, that is air, and it is going in a singular direction. So the travel of light through any medium, for this we are considering air. This is the basic funda of the ray optics. So now let us study one of the important concepts of ray optics, which is called the reflection. Reflection is a concept where light ray hits to a surface and gets bounced back. See this. Light is hitting to a surface and it is bouncing back to the other surface. Since this is an opaque object, some of the light is getting absorbed and some of the light is getting reflected. Now, if we consider the plane mirror, we will see that almost whole of the light is getting reflected. See this. So basically, this is the plane mirror, this is the normal to the surface, that means perpendicular to the surface. This is the incident light, this is the reflected light. Okay, the angle made by both the surface, we will check this angle. See this. Pretty much close. So we have observed that the angle of incidence would be equal to the angle of reflection. So this gives the first rule of the ray optics, that incident angle would be equal to the reflected angle. The second rule is that the normal, the incident ray and the reflected ray would all lie in the same plane. They would all lie in the same plane. Yeah, that's pretty much obvious. Okay. So we have now discussed enough about this plane mirror. Now let us study something about the spherical mirrors. Now, what are these spherical mirrors? Spherical mirrors are basically the curved surface mirrors. Okay, there are two types of curved surface mirror. First, in which the shiny surface on the inner side, and the other one in which the shiny surface is the outer side. Okay, so let us first I give you a gist how this spherical mirror is formed. Consider this to be an imaginary spherical surface. Now, if I cut out a portion of it, let's see this. This would further in future form the spherical mirror. How? If I paint this side, the outer side, then the shiny surface would be the inner one, and this would act as a concave mirror. This is a pretty much concave mirror. Okay. On the other hand, if I paint the inner side, the shiny surface would be the outer side. This would form the convex mirror. Okay. Now let us, in simple terms, in a ray diagram, I can see that that if I paint the outer surface, then this would be the concave mirror, and if I paint the inner side, this would be the convex mirror. Okay. Now let us study some of the terms associated with these mirrors. Center of curvature. The center of curvature is basically the center of that imaginary spherical surface of which part is these mirrors are. Okay, so center of curvature C would lie here for this concave mirror, and for this convex mirror it would lie on the opposite side. That means here. Okay. The center at the center at the shiny surface would call as P, pole. Okay, P, pole. The line joining the P and C in both the mirrors is called the principal axis. And the distance between P and C is called the radius of curvature. Now we have seen in many scenarios that when light gets hit to this concave mirror or the convex mirror, it gets reflected back to a particular point. Since all the lights are getting focused here, this is called the foci or focus. Okay, this is actually lies in exact on the midway between C and P. When lights get strike here, it would get reflect back. And it would be coming, it would go in such a manner that it would look like coming from a particular point, that is focus F. Okay. So now let us study some of the image formation in these spherical mirrors. In these spherical mirrors, we know that when an object is kept in front of the mirror, all the points of that object acts as a point source. It would be better for us to consider at max 2 rays coming out from that object. The intersection of those 2 rays would give us the final reflected image. Now let us study the cases of the light striking the surface. In the first case, this is the concave and this is the convex. In the first case, when the light comes parallel to the principal axis, it passes through the focus. Similar in this scenario. And vice versa, if it goes from the focus, it passes through the parallel to the principal axis. Similar to this mirror. On the other hand, if the incident ray goes through the center of curvature, so in the third case, the incident ray is passing from the center of curvature and it is striking the surface of the concave mirror. We see here that the angle of incidence is equal to the angle of reflection, and both of them are 0. Because why? Because it is striking normal to the surface. That is why it is reflecting back to the same, through the same line. In a similar case, when it strikes the surface of convex mirror, it passes through the same line, and it appears to be coming from this center of curvature, which is lying behind the mirror. Okay. Now in the fourth case, the incident ray strikes obliquely to the surface of the concave mirror. We see here that the reflected ray bounces back obliquely in the other direction, and the angle of incidence is equal to the reflected angle. Similar case appears to be going on here in the convex mirror. Okay, so now let us see the image formation of the concave mirror. We can see here are the different scenarios. At infinity, the image formed would be the point size at focus. If the object is kept beyond C, the image would be formed shorter one between F and C. When the object is kept at the C, that means at the center of curvature, the image would also be formed at here and they would be of equal size. When the object is kept between C and F, the enlarged image would be formed beyond C. And when the object is kept at F, that means at focus, then the image would form at infinity. In the last case, between F and P, if we are keeping the object, then on the behind the mirror, the image is getting formed. Okay, so the concave mirrors are used in a number of applications, like shaving mirrors, for dentists, and to get a solar furnace like this. Okay, so also convex mirror, the image formation of convex mirror are basically of 2 types. First is between infinity and P, the image is forming like this, and the other one is at infinity. The convex mirror uses are used in vehicles and on streets.